Hello everyone, welcome to Science Era. Today we'll be discussing basic probability from chapter number 4 of Business Statistics, 7th edition. In today's lesson, we will discuss basic probability concept and understand what is the conditional probability. Uh, let's start. Basic probability concept. Three concepts you need to understand before you look into the probability chapter is what is probability. You need to able to define probability. A probability is the chance that an uncertain event will occur. It is always between 0 and 1, not less than 0 and not greater than 1. An impossible event is an event that has no chance of occurring. For an impossible event to occur, the probability is 0. Certain event is the third concept. An event that is sure to occur is certain event, and the probability is 1 that it will occur. Next, remember, a probability cannot be negative or greater than 1. So it's always between 0 and 1, not less than 0 and not greater than 1. Now, assessing probability. There are three approaches we can use to assess probability of an uncertain event. So three approaches are a priori, empirical probability, and subjective probability. A priori is based on the prior knowledge of the process. An empirical probability is based on the observed data, while subjective probability is based on the combination of an individual's past experience, personal opinion, and analysis for particular situation. So, when you're looking at in order to calculate the probability of occurrence, we need to divide number of ways in which the event occur. We'll say that event occur in X number of ways over the total number of possible outcome over T. So probability of occurrence will be X over T. For the empirical probability, it's the same X over T, number of ways in which the event occur over the total number of possible outcomes. If we look at subjective probability, we'll see that subjective probability differ from person to person. Why? Because it is based on the personal opinion or analysis of particular situation. An empirical probability, we can find that by using survey. Often we use survey to find the empirical probability. It is based on the observed data. Next we have an example of prior probability. We say that probability of day in January is X over T. So number of days in January over total number of days in 2015. When randomly selecting a data from the year 2015, what is the probability of days in January? So here we have a question. We have to find the probability of days in January. So we will say the total number of days in the year, which is 365 days in year 2015 over and 31 days in January, number of days in January. So we will divide number of days in January over the total number of days in 2015. So 31 over 365. You will get the probability, priori probability, which is based on prior knowledge, which means we know that there is 365 days in a year and there is 31 days in January. So we know that information before. They ask you the probability of days in January. So use your prior knowledge to answer the question. Okay, here I have an example of empirical probability now. Find the probability of selecting a male taking statistics from the population described in the table. So here the table shows male taking statistics and female taking statistics, and male and female who are not taking stats. So you will need to find the probability of selecting male who are taking statistics. So looking at the table, you can see that male 84 males are taking stats, and total number of people who took the stats test is 439. So what we're going to do, probability of male taking stats equal number of males taking stats over the total number of people. So it will be 84 over 439, which is 0.191. Remember, probability is not greater than 1 or less than 0, so it is always between 0 and 1. So if you are getting answer which is greater than 1 and less than 0, it's probably wrong and you need to do it again. Subjective probability. This is the third approach to calculate the probability. Subjective probability differ from person to person, as I said before. A media development teams assign a 60% probability of success to its new ad campaign. The chief media officer of the company is less optimistic and assign a 40% of success to the same campaign. The assignment of a subjective probability is based on personal experience, opinion, and analysis of a particular situation. Subjective probability is useful in situations when an empirical or prior probability cannot be commuted. Next, we have events. Events are often represented by letters of alphabets. So each possible outcome of a variable is an event. Three types of events we're going to see: simple event, joint event, and complement of an event A. Simple event, an event described by a single characteristics, for example days in January from all days in 2015. Joint event is an event described by two or more characteristics, example a day in January that is also a Wednesday from all days in 2015. And complement of an event A, which is denoted by A, comma, all events that are not part of an event A are the complement of an event A. For example, all days from 2015 that are not in January. So all the days that are not in January in 2015 are the complement. Sample space is another concept. A sample space is the collection of all the possible events. For example, all 6 faces of a die, example of sample space, and all 52 cards of a bridge deck. Organizing and visualizing events. We can organize and visualize events using several ways. First I have here is Venn diagram for all days in 2015. You see that a blue circle represent days which are Wednesdays, and pink circle represent days in January, and this purple one in between, which on the part where red and pink and blue circle overlaps, is the days that are in January and are Wednesdays. So this is an example of a sample space. This is a Venn diagram. All events that are not Wednesdays and not in January are outside the sample space. This is an example of representing visualizing events using the Venn diagram. Next we see we can other types of organizing and visualizing events can be using contingency tables. For example, this one here, it also represent days which are in January and not in January, days which are Wednesdays and not Wednesdays in a year. and total number of sample space or outcomes are 365, because in year 2015 or in any year, total number of days are 365. Third type of visualizing event is using decision trees. So this is trees. We can use we can represent same data but in the shape of tree. Next is definition. Simple probability. What is simple probability? Simple probability refers to the probability of a simple event. For example, probability of January and probability of Wednesday. This is an example of simple probability. So if you have to calculate probability of January using the contingency table, what you're going to do? They didn't ask you if days in January is Wednesday or not Wednesday. They just ask you probability of January. So you'll see the total number of days in January 31 over 365, total number of days in year. So 31 over 365, it will give you the probability of January. Same here, probability of Wednesdays. They're not saying that you need to calculate the probability of Wednesday in January or Wednesdays in which are not in January. So you need to take overall Wednesdays in the year. So the total number of Wednesdays is given 52 and the number of years is 365. Number of days in the year is 365. So you divide 52 over 365 and you'll get the probability of Wednesdays. Remember, probability of occurrence is equal to x over t, number of events occurring over total number of events. Joint probability. Joint probability refers to the probability of an occurrence of two or more events, joint events. For example, here we have contingency table, same table we used before. Example of probability January and Wednesday. So you need to calculate probability of January and Wednesday. So days in January and days which are Wednesday is 4. So you divide 4 over 365, you'll get the answer for the you'll get the probability of January and Wednesday. And then other example is probability of days not in January and not Wednesday. So not in January and not Wednesday is 286, not January and not Wednesday. So you divide 286 over 365 and they will give you the probability of joint event which is not in January and not Wednesday. Okay, here I have an example of joint probability. So January and Wednesday, again the same example, number of days that are in January and Wednesday is 4 and total number of days in 2015 is 365. Remember, you do not have to add take 4 twice because 4 Wednesdays and 4 January. No, you only take this 4 and divide by 365. Computing joints and marginal probabilities. The probability of a joint event A and B, we can say number of outcomes satisfying A and B over total number of elementary outcomes. You can find the probability of a joint event like this using this formula. Computing a marginal or simple probability. Remember, a marginal probability of an event is consist of set of joint probability. You can determine marginal probability of a particular event by using the concept of joint probability. For example, if B consists of two events, B1 and B2, and then PA, the probability of event A consists of joint probability of event A occurring with event B1 and the joint probability of event A occurring with event B2 you can use this equation to represent the data. Remember where B1, B2 and Bk are the k mutually exclusive and collectively exhaustive events. So what do you mean by mutually exclusive and collectively exhaustive event? Two events are mutually exclusive if both the events cannot occur simultaneously. If events can't occur simultaneously, they are mutually exclusive, and a set of events is collectively exhaustive if one of the event must occur. So let's see mutually exclusive event example. Mutually exclusive events, events that cannot occur simultaneously. Example, randomly choosing a day from 2015. This is mutually exclusive event. For example, A equals day in January and B equals day in February. Event A and B are mutually exclusive. Days in January cannot occur with days in February. Collectively exhaustive events. Collectively exhaustive events are one of the event must occur. In collectively exhaustive event, one of the event must occur. The set of events covers the entire sample space. Example, randomly choose a day from 2015. A weekday, B weekend, C January and D spring. Event A, B, C and D are collectively exhaustive but not mutually exclusive. A weekday can be in January or in spring. Event A and B are collectively exhaustive and mutually exclusive. Here I have an example of marginal probability. As you know, marginal probability of an event consists of a set of joint probabilities. So marginal probability uses joint probabilities. So they ask you to calculate the probability of Wednesday, which are in January, and plus probability of Wednesdays which are not in January. So January, days in January and days which are Wednesday are 4. So 4 over total number of days, which is 365, plus not January days which are not in January and are Wednesday. Not in January and are Wednesday is 48, plus 48 over 365. So probability of Wednesdays is 52 over 365. You'll get a marginal probability. Here you can see marginal and joint probability in a contingency table. This is just to explain how you look at the marginal probability and joint probability in a contingency table. So here in event 1, probability of A and B, joint event. Probability of A2 and B2, example of joint event. Marginal simple probabilities are probability of B2 and probability of total A2. Okay. Probability summary so far. Probability is the numerical measure of the likelihood that an event will occur. The probability of any event must be between 0 and 1 inclusively. Probability of event A is less than or equal to 0 or greater than or equal to 1. The sum of probabilities of all mutually exclusive and collectively exhaustive event is 1. So PA plus PB plus PC equals 1. If A, B and C are mutually exclusive and collectively exhaustive. Here I have general addition rule. When using general addition rule, we use probability of A or B. So, in order to calculate this, equal probability of A will add probability of A plus probability of B minus probability of A and B. The question here is, how do you find the probability of event A or event B? You need to consider the occurrence of either event A or event B or both A and B. Using general addition rule, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So why do we subtract this probability A and B? We subtract the probability of the joint event A and B from the total because joint event has already been including in computing both probability of A and probability of B. Because it has already been added twice, you need to subtract it to compute the correct result. Next is for mutually exclusive event A and B. If A and B are mutually exclusive, then probability of A and B joint event will be equal to 0. So we'll simplify the rule to probability of A or B equals probability of A plus the probability of B. This only applies to the mutually exclusive events. Next here, I have an example of general addition rule. So they ask you the probability of January or Wednesday. So what you're going to do, you'll add the probability of January plus the probability of Wednesday. In this case, event A is January, event B is Wednesday. Then subtract event A and B. Why? Because they have been including twice. So you subtract to get the correct result. So you subtract the probability of January and Wednesday. Now apply this formula of additional rule and then find the probability. So 31 over 365, total number of days in January 31 over total number of days which are Wednesday 52. So 31 over 365 plus 52 over 365 minus joint events January and Wednesday, days which are January and in Wednesday 4. So minus 4 over 365, we'll get 79 over 365, which will give you about 0.21 probability. You'll know that your answer is correct. Why? Because probability is always between 0 and 1. Computing conditional probability. A conditional probability is the probability of an event given that another event has occurred. So here I have two formulas. Probability of A given B is equal to the probability of A and B divided by the probability of B itself. And then another condition is the probability of B given A is equal to the probability of A and B divided by the probability of A. So you need to calculate probability of A in formula 1. B is given. If B is given, then you calculate the probability of A, where P, A and B is the joint probability of A and B. PA is marginal or simple probability of A, and PB is the marginal or simple probability of B. Next here, I have an example of conditional probability. Of the cars on a used car lot, 70% have air conditioning AC and 40% have a GPS. 20% of the cars have both. So the question is, what is the probability that a car has a GPS given that it has AC? So you need to find P brackets GPS. You need to find GPS given that they have AC. So the information given is they have to have AC and GPS together. First, you need to draw a contingency table like this one. when you finish drawing the contingency table, then you find the probability of GPS given that car has AC. So P GPS and AC over probability of AC. So joint event GPS and AC, the probability is 0.2, and the total number of AC. So you divide 0.2, which is the joint event, joint probability of GPS and AC here, and then divide by 0.7, which is the probability of only AC, and you will get 0.23 2857 as the probability of cars which have AC and GPS. So here you can see that if they give you the condition AC, we only consider the top row from the contingency table, and then you see that from the top row 20% of the cars have GPS, and then 20% of 70%, 0.7, you'll get 28.57% of cars which have GPS and AC. Next we have independence. When the outcome of one event does not affect the probability of occurrence of another event, the events are said to be independent. So independence can be determined by using this formula. PAB is equal to PA, where PAB is equal to conditional probability of A given B. Conditional probability of A given B, and PA is equal to marginal probability of A. So two events are independent when they do not affect the other event if occurred. Next here we have multiplication rule. Multiplication rule for two events A and B. So the multiplication rule for two events A and B states that the probability of A and B is equal to the probability of A given B times the probability of B. If A and B are independent events, then PAB is equal to PA, and the multiplication rule will simplify. So here this PAB will change to PA times probability of B. Okay, lastly it is marginal probability. Marginal probability of an event can be calculated by the following formula, where B1 and B2 and Bk in this K are mutually exclusive and collectively exhaustive events. Thank you so much. This was all for basic probability. I will be doing some past paper examples on this topic in the next video. If you like my video, please subscribe, like, and do comment if you have any queries. For the topic, you have to remember the following. I will be telling you equations which you need to remember for the exams. Equations like probability of occurrence, marginal probability, additional rule, conditional probability, independence, multiplication rule. You need to remember all these. By only seeing the equations, you can summarize and solve probability questions. Thank you so much.